Hey friends, welcome to One Little Coder. In this video, we are going to look at a new machine learning technique called CLIP. This is a pre-trained model and also a new technique. It's a new neural network called CLIP, which is released by OpenAI. There was a release from OpenAI recently called DALI. It almost took the entire media, but something was hidden in that, and that is CLIP. So CLIP stands for Contrastive Language-Image Pre-Training. I don't understand much what does that mean. So basically what it does is it tries to connect text and images in such a way that you can use this connection for a zero-shot classification. So if you are familiar with the zero-shot classification that happens with GPT-2, GPT-3 is, so you actually train text on a very large amount of corpus, and then finally without having a new model that was trained on a new data set, you can use that existing model for a zero-shot classification, and you can actually refer zero-shot classification video that I've done using Hugging Face zero-shot pipeline. I'll link that. So basically without having the need to have a labeled data, so you would be able to do zero-shot classification in that context. And here very similar to that, that's what we're going to do. So what we're going to see in this video is we are going to have a demo of how do you do zero-shot classification using CLIP. That's what we're going to see. Before we even get into that position, so let me just quickly show you what is happening here. So basically you have a text encoder and you have an image encoder, and you pass on this thing, and then you try to find a similarity. In this case, what we're going to do is a cosine similarity between the text that we have given and then the image encoder, the image that we have given, and from that then we are going to create a dataset classifier. So the dataset classifier is structured in such a way that you have a couple of words which are image labels, and then you're going to frame the sentence in such a way that this image is a photo of or something related to this label. So then that is passed on to a text encoder, and now that is used against the image encoder for zero-shot prediction. I know it's slightly ambiguous or confusing if you look at it first. So we'll just get into the code directly and then understand what is happening. So before that, if you want to see a very quick example, so basically what you can do is you can use a CLIP model, and then you can actually give a photo of, let's say, a dog, and then by giving the photo of a dog, now you can give a sentence saying it's a photo of a dog, and then you can have another sentence saying it's a photo of cat. So now CLIP is going to give you the most similar probability or similarity, whether it is a dog or cat. So this way you are going to do zero-shot classification. So let's directly get into the code. So this is not a code that I wrote myself, so it is available on their GitHub repository, so you can definitely check it out. And if you really like this project, so please start the repo. It's always a good thing. So what we see is the collab notebook with the sequence of things that happens. So first, basically, we try to download the model and run the CLIP model, and then we try to find out similarity using cosine similarity between an arbitrary image and text input, and then finally we are going to perform zero-shot classification, image classification. In this case, this image classification principle comes from the zero-shot text classification that happened with GPT-2 and GPT-3. So first you set up your CUDA and then you download the torch version, and then you download the model. Once you download the model, you just have a look at the model parameters. So you have about 151 million parameters and the other information about cap size. Now is the interesting part where you get the input image, and once you get the input image, also you are setting up the text pre-processing for tokenization and all those things. So once you do that thing, now you're going to pass on that image. For this purpose, what we are going to do is we are going to pass on the image from SK image dataset. So let me quickly show you SK image dataset. So SK image dataset has got a bunch of images already available. So we are going to use images from that, like for example, astronaut image, cat image, and then we are going to use some other images like horse, a man taking a picture, photograph, motorcycle. So these are the image that we are going to use, but we are going to also see what will happen if we use a different image. That's a test we are going to do. So we are going to give arbitrary text and input, which means we are going to at least so the default notebook that OpenAI has given with Clip has the right image name and also the right textual description, but what I've done is I've changed that. For example, if you take astronaut, so I have mentioned that astronaut, I've given a description of the cat for an astronaut. So you can actually see the original description of the astronaut is this portrait of an astronaut with an American flag, but what I've done is I've changed it. The same way you can also see for the cat, the name of the cat is Chelsea, and I've said that this is a portrait of an astronaut with American flag. And for page, I've also changed this a page, and for that I've said the page is a black and white portrait of a horse, and let me just comment it. I will call it horse. For horse, I've said this is a page of a textbook from segmentation. So let me quickly run it. So at this point, you would be clear that the key value pair that I've given here is not actually linked. So I'm not giving the exact description of the image that is available, and that could be also visible here. So when we print this image, you can actually see that for the astronaut image, you can see that the description says it's a facial photo of a tabby cat, and for page you can see that the description actually says that portrait of a horse, and for the horse you can actually see that it says the text from segmentation, and for the cat Chelsea, in this case it says portrait of an astronaut. This is just to test or first even validate that even if you give completely arbitrary text and image, does it actually make sense. So the next step that we are going to do is we are going to build features with that. What does it mean? We're going to extract features from this using the model value, and from you can see that we are using the model that we downloaded at the top. So if you see, I'm not going to get into the code, you can actually have a look at it. I'm going to show you the workflow of how it happens. So using the model, we are going to actually encode these. So at the end of this, you would see that we have done text and image encoding, and now we are going to use the image and text features, and then we are going to find similarity between these, and this is the output of it. Let me zoom out a little bit. I think after we change the description, I didn't run it, so let me quickly run it here. Yeah, let me run it here. After I run this, now we are doing the image similarity, the cosine similarity, and so this is given as a heat map, or you can see the similarity value here. So what we actually see is we see an astronaut. The description we had given in this case is a cat, but it doesn't consider that because we are using the pre-trained model that we downloaded, the clip model that we downloaded. So based on that, it is identifying that the astronaut has higher similarity with this text. So basically what we are trying to do is we are trying to use that image, and then we are trying to take that word, the text that we have given, and then we are finding out a cosine similarity between these. And you can actually see for this horse that we gave also, so you can see that the actual description that we had given in this case is a page of text from a book about segmentation, but what indeed it had rightly closely associated is the black and white portrait of a horse, and that is what you see most similar to this. And for the text, you can see it says a page of text from a book about segmentation. So until now, Clip has actually done a great job of taking an arbitrary image and text and connecting them to the closest similarity value that is possible. So now what we are going to do is we are going to use this similarity that we have just created. Now we are going to use it for zero shot image classification. And for that, what we are going to do is we are going to use the CIFAR 100 image. So this is a very popular image data set. So what we have done here is we have used this key image, SK image data set, and then we have created a cosine similarity. And then for these images that we just gave, we are going to find out the closest label that is available from the CIFAR data set. So CIFAR data set has labels, and now we are the classes, and now we are going to find out the closest label associated with the image that we just gave. So technically this image is not available in the CIFAR dataset. That's what makes this zero shot image classification. So this image is not available in this CIFAR 100 dataset, but we are just using the classes that are available, the labels that are available there, and then we are trying to do zero shot classification. And then for zero shot classification, we are actually using the similarity, the cosine similarity that we used, and we are multiplying it, we are making it 100 times, and we are giving that as the logit for a softmax operation. So that's what this step, if you see, this is extracted as part of the cosine similarity activity above, and then we are using that as an input to the softmax, and then we are using that as our probability in this case. So let us quickly run this. So first we are downloading the CIFAR 100 files already downloaded and verify, and the way we are doing that is, this is the most important thing. So we are framing the sentence as it is, this is a photo of this. So it's basically trying to perform a classification task, and then it will identify the most closely associated probability. So based on that, it can give you different labels. So we have 100 labels, and then from that it's going to identify the closest identified label or the text that is associated with this image, and these are the images. Okay, so what we can do is, now let's run this. You can see the torch size, and let's run this. So this is finally going to give us the actual let me again zoom out. So you can see that for astronaut, it has identified the closest as woman and girl, and for the text, it has not correctly identified it talks about bed and all these things. For the horse, it has closely identified with cattle and camel, and for the cat image, I don't actually what does a sweet pepper means, maybe it's a cat variant, I'm not sure, but tiger is the closest, you can see. For the coffee cup, it has closely associated with cup, bowl, and for motorcycle, it is definitely closely associated with motorcycle and bicycle, and for the rocket, skyscraper, and for the photographer, it says boy, man, and yeah, so something probably in the background it has identified as rocket. So just to quickly further validate this exercise, let's pick up a different image from the ski image dataset, and then let's try to find out. So what I want to pick up in this case is, I think there is an image of a grass. So let's use that image. So let's go here and then see how the image looks, grass, and then let's see how the image of the grass looks. So this is how the image of the grass looks. So you can see the grass image. So what we are going to do is, we are going to say, I'll probably comment one of these to avoid, I'll probably comment horse, and then I'll say that okay, I'll comment the coffee and then say grass. It's a photo of a green grass outside the house, maybe. I don't think it's required, yeah, but yeah. And then let's again do the task again. So we are going to pass on that image, find the, you can see where is the grass. So it says grass, a photo of green grass outside the image. We are going to build the features. So we have our encoded text, image features and text features. Then we are going to find the cosine similarity between these two features, and then finally it says this is the grass, and then the closest it finds out is a photo of green grass out the house. So it also has a slightly closest association with the black and white portrait. That's because this image is in grayscale, so that's another probable reason why it has a close association with that. So you can see the same thing also here in this case, which is the person who is looking at, you can see that it's a person looking at the camera on a tripod, but it also looks like a rocket launch pad. So in the background, if you see, and it also has the closest association with the black and white portrait. So again, it's once again validating that clip model is really useful in identifying image similarity from the natural language that we give. So after that, now again, I think this model is already downloaded. So let's quickly see what it is predicting closest to the grass that we gave. It's doing its job, so everything stays same except the grass. If you see, it has actually again done a very good job. It says it's a lawnmower. I think the closest is lawn, because the grass is it has associated probably the grass with the lawnmower's image, because Most of the time probably you would have seen lawnmower with the grass behind it, lawn behind it, and then it also has found out it's a forest. So these are the two closest image. So Clip seems to be doing a great job in doing zero shot classification, and you really didn't have any pre-trained text. So basically what you have done is you have downloaded the Clip model, you have done cosine similarity with a few images, and then used those images and the similarity value to actually do zero shot classification from a totally different data set that is available on the internet. And if you read this blog post, that's primarily their objective as well, and their benchmarks are really good. If you actually see ResNet 101 on ImageNet dataset, so Clip, which has not been trained or optimized based on that particular dataset, is doing almost closer to or slightly better than ResNet 101, which was actually trained on ImageNet dataset. And this is actually a great thing in a lot of different aspects for image classification and using deep learning. Few advantages that they have listed here is the efficiency. You really did not if you see how they have trained, the best performing Clip model was trained on 256 GPUs for 2 weeks, which is almost similar to the existing image models. So it didn't actually require insanely excessive computation power for doing this task. The other thing is it's also flexible. You don't have to necessarily train everything from scratch. You can modify existing Clip models. The other advantage that I actually wanted to highlight is you don't need training data for every time you want to do image classification, because acquiring data set is actually very an expensive and also error prone task. So for you to do deep learning, a lot of times you need the data set, and they have given an evidence saying that ImageNet data set, which is one of the most popular image data set that's available for computer vision problems, 25,000 workers annotated 14 million images on 22,000 categories, and this means that it's very expensive, time consuming, error prone, because humans tend to make errors. And in contrast, what Clip actually does is it takes the existing text image pairs from internet, and it's going to do zero shot classification for you, which means you don't necessarily need human beings to annotate your current image. You can just pass it on to Clip, and then Clip would probably give you the closest probability. We don't say that Clip is 100% right. That's not the case anytime with machine learning, but it is going to mitigate a lot of current problems that are available in the standard deep learning approach that they are saying. So this is really a great thing. You can definitely check out what Clip does and what is the potential, and then the details behind the concept of Clip. But I would suggest you start right away with the code, play out different things. So instead of ski image, you can give your own image and then try to find out how that image works out, or you could pick a different data set. Definitely give a star on their GitHub repository. This is an amazing task, and kudos to the team for providing a Google Colab for a lot of us to straight away get started with. And you can also see some other information about how you can use it, and also the kind of the API that they have created with the Clip. So I hope this video was really helpful to you in understanding one of the most recent advancements in image classification, I should say. So especially I think if you go back a year or two ago, there was a very popular image. There was a very popular title saying that NLP's transfer learning moment has come. So transfer learning was a big concept in image classification, and then NLP borrowed it for a lot of things. So that was like the title of that article. I think I can find that article. NLP's transfer learning moment, right? NLP's ImageNet moment has arrived. That's the name of that. So this was the name of it. Now what we actually see is the advancements in NLP has actually gone to a different level, that now we are taking the learnings that we have got from NLP and then we are trying to apply it back to the image world, which means the computer vision. So 2020 was all a lot about NLP taking huge leaps with GPT-2, GPT-3, GPT-3 API from OpenAI, and a lot other highly competent models coming out of a lot of these large organizations. Even a couple of days back, Google released a 1 million, I think 1 trillion or 1 million, 1 trillion probably, the model trained with that. So all these things happened in 2020, and I think 2021 is about now taking the learnings from NLP and then applying it to image data set or any other media data set that was not possible before. And then this is going to, zero shot classification is definitely going to be a huge area of interest in a lot of organizations where they do not have pre-trained model or they do not have resources for pre-training. Definitely check out the video that I'm going to share with you about NLP zero shot classification, simply using a bunch of lines from Hugging Face API. I hope this video was helpful. If you like this video, please give a thumbs up and subscribe to the channel if you have not, and share it with your friends. Until next video, take care of yourself. Peace.